Right now, deep in the bones of your arm, something is happening that shouldn't be possible. Cells inside the bone are making a hormone. Not calcium, not marrow, a hormone. It's leaving your skeleton, entering your blood, and racing to your pancreas, to your brain, to the glands sitting on top of your kidneys. Your bones are a gland, and nobody told you. Your body is doing something incredible right now. Come see it. Everything you were taught about your skeleton is a little bit wrong. The scaffolding, the calcium bank, the frame the muscles hang on. All true, but not the whole story. For most of medical history, your bones were considered inert, a hard structure made of minerals holding you up. Then, in the 1970s, scientists noticed a strange protein pouring out of bone-building cells. They called it osteocalcin. Osteo, meaning bone, calcin, from calcium. For decades, they assumed it did what everything else in the skeleton did, help build bone. Then, in 2007, a geneticist at Columbia University named Gerard Karsenty tried to remove it from mice. He expected their bones to weaken. Instead, the mice got fat. Their blood sugar climbed. They couldn't reproduce. Their brains slowed. The bones weren't making a builder, they were making a messenger. Here's what happens, right now, inside you. Deep in the marrow of a long bone, say the femur in your thigh, sit cells called osteoblasts. They're the sculptors of your skeleton. Every year, they replace roughly 10% of your bone. But while they're building, they're also secreting. They release a small hormone into the bloodstream, Osteocalcin. And this hormone doesn't stay near the bone. It travels. Its first stop, your pancreas. Tucked behind your stomach, the pancreas has clusters of tiny cells that make insulin, the hormone that manages your blood sugar. When osteocalcin arrives, it tells those cells to make more insulin. Your bones are helping you handle every meal you eat. Then it moves on to your fat cells and to your muscles. It coordinates how you burn fuel. In older mice missing osteocalcin, exercise performance collapses. Restore it, and the old mice run like young ones. Then it climbs into your skull. Osteocalcin crosses into your brain. In the region that files your memories, it helps the neurons stay connected. In older mice missing osteocalcin, memory fails faster. Restore it, and their memory comes back. But the strangest thing your bones do happens the instant you get scared. You know the feeling. A car swerves at you, a footstep behind you in the dark. Your heart pounds, your breath quickens, your palms sweat. You've heard this all your life. It's adrenaline. The fight or flight response, they said, comes from the adrenal glands sitting on top of your kidneys, dumping adrenaline into your blood. In 2019, Karsenty's team ran an experiment that broke that story. They took mice that had been engineered so their bones could not make osteocalcin. Then they scared them. The mice barely reacted. No racing heart, no spike in blood sugar, no fight, no flight. Then they took normal, calm mice, and they injected a single dose of osteocalcin. The mice froze in place, heart hammering, temperature climbing, blood sugar flooding their veins. No predator, no danger, just osteocalcin. Then they tested people. They put humans through a stressful public speaking task and a cross-examination. Within minutes, Osteocalcin surged in the blood. The fight-or-flight response couldn't get started without something coming out of the bones. Here's the sequence put together. The instant your brain recognizes danger, it sends a signal down the nerves. Not to the adrenal glands first, to your skeleton. The osteoblasts flood the blood with osteocalcin. Within seconds, it reaches the adrenal glands, and only then does the full fight-or-flight cascade fire. Heart rate up, breath fast, fuel released. You are ready to run. The English language has a phrase for this: scared to my bones. It turns out that was never a metaphor. There's one more thing, and it might be the strangest of all. Karsenty and his colleagues asked a question. Why? Why would bones evolve to do this? And their answer changes how you look at your own skeleton. Bones, they propose, didn't evolve just to hold us up. They evolved to help us escape. A predator lunges. The brain sees it. The skeleton floods the blood with osteocalcin. Sugar rises. Muscles wake up. Heart pounds. You run. The skeleton is the fastest emergency system in the body, because in the wild, milliseconds decide who lives. Every bone in you was first a survival organ. The scaffold came later. So the next time you feel that jolt, the drop, the racing heart, the certainty something is wrong, remember what's actually happening. A signal is racing from your brain to your femur. A cell tucked inside your bone is releasing a hormone into your blood. And within seconds, that hormone is reaching every organ that needs to know. Wake up, move, live. Your body has a hidden emergency system, and it's built into the very thing you thought was just holding you up. Your bones are alive. Your bones are a gland. And right now, they are doing something incredible. You just came to see it. If you like this one, there are more hidden systems inside you than you can imagine. Subscribe. We're only getting started. See the living.
Vivovue.